problem. So x squared plus x, how does it look? Is this one-to-one?
No.
Absolutely not. So it has to do something with this then. Now imagine just this branch. Is this one-to-one?
Yes.
Right, but this is not. There is no way, no reason to restrict the domain of this function. It's all real numbers, right? It's defined everywhere. But if I'm asked to find f inverse, it doesn't have a function that is its inverse. That's why they specified this. Okay, good. So again, when we graph this function, let's find its vertex. I want to graph the vertex, find the vertex. You remember negative b over 2a, negative b over 2a. So this is definitely the vertex, because that's where x is. So if I want to graph this function at x equals negative 1/2, I will have 1/4 minus 1/2 is negative 1/4. So I will have this graph. This is the graph of f of x equals x squared plus x for x greater to and equal to negative 1/2. We agree? Is this one-to-one?
Yes.
Yes. And this is the vertex. Okay, so can anyone give me the domain and range? I calculated this, so I just plugged it in. So let me tell you, and let me show you here. So negative 1/2 squared is 1/4, but minus 1/2, this makes it negative 1/4. So the vertex is negative 1/2 comma negative 1/4. So f is defined on, again, can anyone give us the domain? With a bracket to infinity. Good. And the range? Awesome. Negative 1/4 to? Awesome. I don't have the inverse function, but I can determine the domain and range. I know nothing about the inverse function, but I can find the domain and range. I don't know the graph, I don't know how it looks like, I don't have the equation, I don't have anything, but I have the domain and range. Say it again. Exactly. Negative 1/4 infinity, negative 1/2 infinity. Absolutely. And now I'm ready to find the inverse. So, first step. Let me copy it here. So f of x equals x squared plus 4. Step number 1. Oh, I'm sorry. How did I come up with that? I don't know. So x squared plus x. First step. I replace. Yes. So y equals x squared plus x. Step number 2. X equals y squared plus y. Good. What type of equation is this in y? Exactly. Messy. Messy. So this is y squared plus y minus x equals 0. One of my professors, I had probably one of the best, and I also had probably one of the worst. One of them, he would return a test, and we would ask him, can you show us a problem from the test? He will start the problem, he will write just literally just this, and say, from here on is messy, you do it, and move on to something else. I never learned anything from him. So, okay, so what do we do here? He never showed anything, nothing. No conversation, no. Good. How do I solve this? I only have one way. Yeah. So then y equals negative b square root of b squared minus 4 times a times c over 2a. But minus 4 times negative x will be positive 4x and divided by 2. And I lost track of my numbers, so this is 12. And in step number 4, I'll have as many question marks as you can write, and I'll say no way. It can't have two functions. Which one? I have negative 1 plus the square root over 2, and I have negative 1 minus the square root over 2. I can't have two functions. If the function is 1 to 1, the inverse will be 1 to 1. I can't have two functions. But the answer is right here. What type of answer will I have? Obviously, the domain has to be 1 plus 4x greater than or equal to 0, which it is. But what type of answer do I have to have? A number greater than negative 1/2. Which of these two is not a number greater than negative 1/2? Exactly, they're both minuses. Because I already have negative 1 minus another quantity. So I will say no and say only f inverse equals exactly. It's the only way. It's the only one that will have an answer here. The other one will start with negative 1 minus, and it will go higher, larger and larger in the negative way. It will not be a number greater than negative 1/2. But as you noticed, this would have not been possible before analyzing the graph of the given function, identifying its range in order to determine the domain and range for the inverse. Based on this, I make my selection. Any questions? Okay, last thing that I would like to look at a couple of modeling problems on page 220 and page 221. Okay, let's say, are you interested in fencing a field? Volume of a box? Both of them are very important. Fencing a field. Okay, very good. A property owner wants to fence a garden plot adjacent to a road. So this is problem 23 on page 220. As shown in the figure. So the figure is this. I'm copying the figure for you. Here, this is a road, and this is the garden. Or a property. The fencing next to the road must be sturdier and costs $5 per foot. So this piece, $5 per foot. But the other fencing costs just $3. So this piece, and this piece, all of them will cost $3 per foot. The garden is to have an area of 1,200 square feet. Find a function that models the cost of fencing the garden. Find the garden dimensions that minimize the cost of fencing, part B. And if the owner has at most $600 to spend on fencing, find the range of length he can fence along the road. A lot of work, right? Okay. So first question. Find a function that models the cost of fencing the garden. We are also told to use the length as x. Well, I also have to use another variable for the width. I am given the area. That's my starting point. What do I write? Equals 1200. Awesome. Perfect. Now, the cost function. Cost function. How do I write the cost function? Obviously, it has to have two pieces. Piece number 1 and piece number 2. Why? Because we have two categories of wood. One that costs more than the other. Good. So the first part, let's say the one that costs more. How will I write it? If you have X feet and it's $5 per foot, how much do you pay? 5X. And that is done. Awesome. Good. What about the other one?
20x.
Careful. We have a Y and a Y, and we have an X. So I have 3, and in parentheses, X plus
2y.
Very good. However, I can't have two variables. In this class, I can only have one variable to deal with. So I'm going to call this cost of X. I have 5X, I have 3, I have X, and I have 2, but I have to come up with a relationship for Y that depends on X. I can't put a Y in there. Is there any source from which I could get Y from? Exactly, it's right there. So how do I get Y?
Divide by x.
Very good. And I put it here. 1200 divided by X. Very good. Of course, I will distribute in the hope that I can combine like terms a little bit. So I will distribute 5X plus 3X plus 3 times 2 is 6. 6 times 12 is 72. 7200 over X. Combine 8X plus 7200 over X. We created the function that represents the cost of the fencing of this garden. Any questions on any step? Anyone? Please stop me if you have questions. This problem this was part A. Are we okay with part A? Part B, it says find the garden's dimensions that minimize the cost. Min of cost. Find X. However, without calculus, we can't do this. And if you look in the book, you'll see the calculator symbol next to it. So let's go ahead, plug it in Y equals. $8X plus 7200 divided by X. I'm interested in looking at the graph. I have to look at the graph. But I don't know where to look for the graph. So every time I put a function in the graphing calculator, I have to ask myself, okay, what is its right? So let's analyze this because I don't know what to do. I don't know where to look for the minimum. So, okay, obviously X is a length.
Right.
It must be greater than 0.
Right.
That's one thing. Secondly, if the area is 1200, The maximum I can have here is, I shouldn't even say 1200, but if it's the square root of this, right, that will be a square, right? So I'm going to go to, let's say, 1,000. That's way too much. So the square root of 1200 is a little bit more than 100, right? So I shouldn't even go beyond, let's say, less than 120. So I have an idea. Now, I'm not interested in the negative portion of the graph, right? There may be a negative portion, but is there a point of graphing the negative side of y? No. Can I eventually have a cost of negative $50? No. So now I have an idea of where to look. So let's go to window. I will put 0. I will not exceed 120 for x with a scale of 40. The y minimum, I don't care for negative value, so it's going to be 0. I have no idea what to put for y maximum. So I am going to say 500 with a scale of 100. And click enter. Graph. It's way up there. Okay, so I have to go back. But do you understand the thinking process?
Yeah.
I had no idea where to look. I have to think to see what the viewing window should be. So 500 for y maximum is nowhere near what I need. So I'm going to put 2,000 with a scale of 500. And press enter again and see what happens. Ah, much better. Is there a minimum?
Yes.
Is there a local minimum?
Yes.
Right. Where? Well, my tick here is I had between 0 and 1,200. So this is what, 400? What did I put? I can go back. I put 120. Yes. So this is 30, 30, and 30. 40, 40, and 40. Right? So I know I'm looking for a minimum. I will give the calculator between 0 and 40. Okay. So I go to second and calc. I'm looking for a minimum between 0 and 30. I don't want to guess. I meant 40. Sorry. So I want a minimum. I want 0 for the left bound. I want 40 for the right bounds. Make sure that it passes. Say it again.
How do you make it so you enter in the value? I need it to the back.
Left bound 0. Enter. And the right bound 40. Enter. Yep. Are we okay? Are we okay? Okay. And now I don't want to guess. I press enter again, and it gives me the minimum. The minimum is at approximately 30 feet for the length, and we'll determine the width in a minute. And y is what? Which function did we plot? Cost. So when x is 40 feet, the
Cost.
of the fencing is?
480.
We could have not done this without calculus by hand. We had to determine the derivative and set it equal to 0. Yes, it is. So that's why it has the calculator symbol next to it. So x equals roughly 30 feet, approximately. And minimum cost is $480. So what would you tell the farmer? Sir, if you want the minimum cost for what you're trying to do, make sure that the length is 30 feet. And the width, I can determine the width. If this is 1,200 divided by 30, obviously the width in this case must be 40. Right? And your cost will be minimum. Okay. If the owner has at most $600 to spend, now it's a different story. So cost at most 600. Now the problem is different. He's not looking for a minimum cost. He says, "Oh, I can spend 600 now." If the owner has at most 600 to spend on fencing, find the range of length he can fence along the road. So in this case, I would like to stop to give you the classwork, and we can finish this, but we have to write 0 less than or equal to 8x plus 7200x less than or equal to 600. And again, we will have to look at this. If it's not factorable, I move 600. Of course, I use the chart to study the sign, and if it's not factorable, then I will have to graph it again. But this is what is going to be a different function. It will be the function 8x plus 7200 over x minus 600 that I graph now. And then I find the range of length he can fence along the road. So let's finalize this so we don't forget. So on Wednesday, I would like to show you from modeling one more problem at least. One problem from modeling. Also, and review for test 1. Okay? I'm hoping that you can finish all those problems. Everything, so you can ask questions and review. So all these, please, I'm kindly asking you to do everything till here so you can ask questions. So all these problems, please. If 5 of them are the same, do 2 and move on. Once you check the answer and it works, move on. Okay, so then we'll review for the test. And when we're done with that, hopefully if we have time, we'll continue with, we'll start trigonometry.